Today we are going to study kurtosis, and this time we are not going to solve any question. This will be a theoretical study of kurtosis without any question. If we consider the historical definition of kurtosis, we can say that kurtosis exhibits the extent to which the curve is peaked or it is flat topped. Here I am using the word exhibits because there's a lot of controversy in this that kurtosis tells you or kurtosis is basically a measure of. No, I'm telling you that kurtosis, it exhibits the extent to which the curve is peaked or flat topped. Okay, so what does it measures? It measures whether the data is heavy tailed or light tailed. And why it is caused? It is caused by the variability in the distribution. What do we mean by the variability? If the items concentrate too much in the center, then the curve becomes like this, the blue line types. When the more frequency is at the center line, then the curve will be of first type. And if the concentration in the center is comparatively little, then the curve will be the second line, that is the green one. And if the concentration in center is comparatively little, then the curve becomes platykurtic. Then the red line curve appears. Concentration in center is less, and then we have this tail here. Since the concentration in center, the blue line is more, the tail here, you can see here, the tail. So if the kurtosis is 0, then the curve will be of the type Mesokurtic. Here the kurtosis is 0. That is, we can say that a normal curve. Through this normal curve only we check whether as per the normal curve it is more peaked or it is more flat topped. It exhibits it, but it doesn't defines it. Okay. So how many types of kurtosis? Leptokurtic, the first type of curve, the item concentrate too much in the center. So this type of curve is called the leptokurtic curve. This curve is the leptokurtic one. Okay, if the concentration in center is comparatively little, then the curve is platykurtic. So this curve. So as compared to the first one and the last one, the curve in the middle is called Mesokurtic curve, and we also say that it's a normal curve. So kurtosis is 0 for this curve. Which curve? The Mesokurtic curve. And this is also called the normal curve. We sometimes also call this kurtosis as a positive one, and we call this one as a negative kurtosis. And this one is obviously our normal curve. So how you define the positive one? When the tail of the distribution are heavier, thicker, but the center of the distribution is thinner. You can see the center of the distribution, it is quite thinner. In comparison to the normal distribution, then the kurtosis is positive kurtosis. And when the tail of the distribution are lighter, thinner, but the center of the distribution is thicker. You can see the center of the distribution, it is quite thicker as compared to this M or normal. Then we call it a negative kurtosis. Let us understand how do we measure the kurtosis. Kurtosis is measured by the coefficient beta 2, and this coefficient beta 2 is given by mu4 upon mu2 square, where this mu4 is fourth moment about the mean and mu2 is second moment about the mean. So this is fourth and this is second one. So the greater value of beta 2, the more peaked the distribution is. Okay. So let us move to one more way to express kurtosis in terms of gamma. So gamma 2 is given by beta 2 minus 3, So if beta 2 is equal to 3, the curve is a normal curve. So if I go here, I'll say that here the value of beta 2 is equal to 3 because the curve is a normal curve. Okay, if beta 2 is less than 3, then the curve is a platykurtic curve. And if beta 2 is greater than 3, then the curve is leptokurtic curve. So what all we have to do in order to check kurtosis or in order to measure kurtosis, we have to find the moment and then apply this formula mu4 upon mu2 square. And if this comes out to be 3, then you can say that the distribution is a normal distribution, or you can say that it's a mesokurtic distribution. If it is less than 3, then it is platykurtic. If it is greater than 3, then it is leptokurtic distribution. The normal curve is a mesokurtic one, more peaked is a leptokurtic one, and if it is flat topped, it is platykurtic one. For the middle one, that is mesokurtic, the value of beta 2 comes out to be 3. If it is platykurtic, then the value of beta 2 is less than 3. If it is leptokurtic, then the value of beta 2 is greater than 3. And you can also say that how the items are concentrated. Leptokurtic, too much items at the center. Then mesokurtic, the normal one, and if the concentration is comparatively little, then it is platykurtic. If you still have any questions or queries, please write it in the comments, and in the next lecture we'll do questions on kurtosis.